Hey everyone, thank you for checking out another video. This tutorial is going to be about recreating this generative orbit tool that I created recently. It's just a really neat looking project. It's another solar system attempt by me. This time we're using HSB color mode and we're playing with some saturation with the rings and the planets. There's some circle packing going on for the stars. There's this cool effect of the stars being within the outside orbit. It's just a neat looking thing. So I wanted to go over how to make that with p5.js. That's where I'm going to spend most of the time in this tutorial. And then at the end, I also created a Python version using the processing Python module, and I'm going to look at that briefly. We won't do a full tutorial, but mostly just show some of the differences. But the cool thing is that the logic is almost exactly the same. So this is actually a really simple project. It's just circles. Hopefully that sounds fun. There will be a link in the description to the source code for both the JavaScript version and the Python version. So if you don't care about the video, you can just click on those links and check out the source code yourself. So right now I have a base set up in this editor called brackets, and I've got a live preview running. So right now I'm just drawing this rectangle. It's basically just the canvas, and I'm setting it to white. I was drawing that circle. We do want to set it, I did want to show you that the canvas was being drawn, so you can see that it's white, but we are going to set it to black. So background 0. So when we think about making an orbit tool like this, let me actually bump up these star colors just in case. Star brightness, generate. Okay, the stars are a little bit brighter. Maybe that, I don't know how well they're going to translate on the video. When we think about making this tool, if we think about the logic of creating an orbit like this, there's a few different elements. So we have the sun in the middle, we have the stars, we have the orbit rings, and we have the planets themselves. The order in which we draw those is fairly important because we want the stars to be behind the planets. So we're going to draw the stars first. Draw the stars. Then we're going to draw, we can draw the sun, draw the orbits, and then finally draw the planets. Now, we can do this in a lot of different ways. The way I usually like to do it is kind of generate all of the objects themselves and then go through and draw those objects. So for the stars, if we want to start there, we've already drawn the background as black. We do want to draw the stars, but we don't understand the boundary at which they're going to be drawn yet. We don't know how big the orbits are, so we need to define a few variables. So we can start with sun size. So we want the sun to be, let's just say 200. We'll say the orbit, we have to think about the distance between these orbits. So let's just say 100 for now. So distance, orbit, distance, 100. Planet size we'll get to in a little bit, but let's just start there. Let's start with the sun size and then the orbits. And even though we're supposed to draw the stars first, we're going to draw the sun and the orbits first just to make sure that we know where everything lies. So when we draw the sun, we're just going to draw it in the middle. If we want to do that and kind of preserve some ability later for rotation, which I'll talk about in a little bit, we can go ahead and translate. So before we do anything with the sun, the orbits, and the planets, we're just going to translate to the middle of the image. So translate width divided by 2, h divided by 2. So now we should be in the middle, and then we can draw circle 0, 0, sun size. Now if I save that and I come over here, we've drawn our sun. The color is not randomized yet, but we'll get to that in a minute. So we have the sun. Now if we want to think about drawing the orbits, I guess we also need to think about how many planets we want. So planets equals, or we'll say planet count equals 10. So we'll start a loop for var I equals 0. I is less than planet count, I plus plus. So we're going to go through every planet. Let's just start just with an example. Circle 0, 0. That's the cool thing about translating to the middle is that everything's going to be at 0, 0 now, even the orbits. Circle 0, 0, and then the size, it needs to progressively get larger. These orbits are much larger than the size of the sun. So we'll just say sun size plus. So we definitely want to start at larger than the sun size. And then we'll say sun size plus 100. Or actually, it's the orbit. We've already defined the orbit distance. Orbit distance times I. And then we'll save that. We'll go this way. So it's still filling. So every orbit is still filling just like the sun. So before we draw the orbits, we need to say no fill. Save that. That did not work, but I think it's because there's no stroke. So if we say stroke 255, we come over. Okay, hopefully you can see that. I never know if the thin lines will translate to the video very well. So stroke weight 3. Then we come over. So they're a little bit thicker now. So we have the orbits. That works pretty well. We may be drawing an orbit right here on the sun. I'm not totally sure about that. We should be, because when I is equal to 0, then we're just drawing it at sun size. So what I would do is just cheat a little bit and just set that to 1. And then when we come over here, you couldn't see it before, but it was there and now it's not there anymore. So we have the orbits, very easy. Now we can just change the orbit distance to something like 50. Everything stays the same, but our orbit gets smaller. It's pretty cool. We'll leave that at 100. So we've got the orbits. We're still not doing anything with the color, but let's do the planets now, and then we'll circle back to the sun, or the stars at the very beginning. So we're translated to 0, 0. So if I just say, let's do the planet count thing again. Var I equals 1. I is less than planet count. Actually, we don't need to do this. We don't need to do this outside of this loop. We can just do it within the loop, because we're drawing the orbit, and that's great. But we can just put the planets within here. So we'll just say draw planets. So if we were going to draw the planet on the line, on the orbit line, then we would draw it circle 0. Let's just think that we're going up. So we're going to go, let me actually save this since we changed it back. So we're going to go up. We're going to draw a planet here, a planet here, a planet here, kind of along that y-axis. So if we're drawing a circle for the planet, then we would say negative, since we're going up, we're going to go negative sun size, basically this distance here. So let's just pull this in. We'll say negative sun size, like that. That's where we're going to put it. And then we'll say planet size, let's just do 30 for now. That did not work, and that is because we actually need to divide this by 2, because we're, well, you'll see. So I'll divide this by 2. It's a little bit different when we're doing positioning rather than, the radius of a circle. So now our planets, let's make this height a little bit bigger, just so we can see the full deal. Okay, so we've got the planets. They're not filling, but we want them to fill, so we can fix that. We'll say fill, and we'll just say 255 again for now. The problem is this will need to come in to below the circle. So we'll bounce between no fill and fill. Now we come back. We've got the nice orbit. We've got the planets, but they're all in a line, right? It looks cool, but it's not very realistic. We want them to be at different parts of their revolution, independently of each other. So we can just rotate. We're translated to the center. So if we rotate, we're just going to rotate from the center. We're going to rotate around the center, which is exactly what we want for the planets. So before you draw the planet, let's push our current position, our current orientation, and our current rotation. Or really, I guess it's our current translation and our current rotation. We're going to push that onto the stack. And then after we draw the planet, we're going to pop it off. So we can push. Now, whenever we say pop, we just go back to wherever we were. We're not going to translate again, but we are going to rotate. So we'll say rotate random to pi. And now our planets are in random orientation. I can save that again and come back, and they're in a different orientation again. So they just rotate randomly around the center, which is where we've translated to, and everything looks great. The last thing I want to do before we go to the stars is I want to break this orbit line just a little bit. So you see on the sides of the planet, it's like they're connected to the orbit. I think it looks just a little bit better if there's a little bit of a break. So on my example, there's some space between the end of the orbit line and the planet. That's personal preference. I think it looks a little bit cooler. So the only thing we have to do to accomplish that is we would fill at the same color as the background, which for now is just black. And then we're going to draw a circle of the same size as the planet, but just a little bit larger. So this 30, instead of 30, we could do 50, and that would look okay. Oh, okay, so we need to fill 0, but no stroke. No stroke. And then there you go. So now we get that cool little separation. Again, personal preference, but I think it looks a little bit better. So we've got the planets, the sun, the orbit. Now we just need the stars. And that's really, I guess, the fun part, because we get to use this function distance. because we're going to compare the stars. Like I said at the beginning, there's going to be a little bit of circle packing. It's not extremely complicated. We just don't want the stars to overlap too much because they can become a little clustered. And I think it looks just a little bit better to have them separated, or just a little bit of breathing room between the stars. We also want to use the distance function to check the distance of the stars from the center of the solar system. Just make sure that they're not outside of that furthest orbit. So as we go through and we start drawing the stars, the goal is you generate a random position, random x and random y. So we can just start doing that. So let's say var I equals 0, I is less than, we'll say star count, I plus plus, and we'll come up here and we'll add var star count equals 1000. We'll just start with something simple right now. So we could do this. We could just say let ran x equals random w, let ran y equals random h. And then we'll just draw circle ran x, ran y. Now it is worth noting that this is before we have translated. So that's why we're going to work off of essentially 0 to w and 0 to h, because we're not, our origin at this point is still at 0, 0 in the canvas. So if I check out what we've done, we've got stars all over the image. I'm not sure if you can see them. Let me bump them up to 4. So we have stars all over the image. It looks pretty cool, right? We could do that. We could fill in the star field, and I think that would look great. But just for the purposes of the video and a little bit of a tutorial, I am going to put them or restrain them within the outside of that orbit, or within the inside of that orbit. So all we need to do is say let valid. We're going to check the validity of every star that we generate, essentially. So let valid equals true. Every star will start as a valid star, and then if we find a reason that it is invalid, then we just won't draw it. That's the goal. So let valid equals true. If valid equals false, then we would, if valid, well, that should be if valid equals true. If valid is still true, then we would draw it. So we can say if valid, then we would still draw it. So how do we check if it's valid? We just need to check the distance between itself and other stars. So up here we can say, I guess during the setup we can say let stars equal a blank list. If it's a valid star, we also want to push it onto that star list. So push, and it's just going to be a list of the positions. So ran x, ran y. So now we have the stars. All the valid stars are going to be on there. So if it's true and it's valid, then we can do this again, and everything's fine because we haven't given it a reason for the star to be invalid. For our first check for validity, we're going to check the distance between each star and all the other stars that currently exist. So for var, I think I can do this, var n, var I, well, we can't do I, var j n stars. Can I do this? I don't think I did this when I wrote this program originally, but I think we would say return, or we would check the distance if distance between ran x, ran y, and stars j 0. So that's the x position of whatever star this is within the stars list. Stars j 1, which would be the y position. So if the distance between these is greater than, or we would say less than, to check it, let's just do less than 10. Then we'd say valid equals false. So now if we run this again, oh, okay, so that was dumb. The reason it's not working is because every loop, I'm just resetting the stars function to empty. So it's never going to be invalid because, yeah, so that's just whatever. So we need to set that before this. So it's a var stars equals that. And then I think, now we've got some distance. So once I pull that list out, it works. Hopefully you can still see these circles, but you can tell that they're pretty evenly split up. Well, it's not about them being evenly, it's just they can't be closer than the 100 here. So if we set that to 10, they get a little bit closer, but there's still some separation. You can put as much separation as you want. So we've checked the validity of the stars based on each other, and we can set this value to whatever we want. We can come up here and say var star distance equals, we can just say 4, and then star distance but we also want to keep the stars within that outer orbit. And I think to do that, for every star, or not for every star, for this star specifically, after it's valid with these, or you could check it before, maybe that would actually be better. We could say if distance ran x ran y, width divided by 2, h divided by 2, because right now, again, we're not translated. We're still at 0, 0 on the canvas. If that distance is less than, we want it to be the distance of the final orbit. So this is the distance of the final orbit. If I, well, really, this is the distance. If I is equal to planet count minus 1. So we can say if it's less than this, and then I would just be planet count minus 1. I think we can do that. That's that, and that's that. So we'll say if that's true, then valid equals false. And now that does not work. Sun size plus orbit distance. So let's just make sure that this works first. So we're going to set this to 200. That did not work. If distance. Oh, another dumb mistake. So now I'm checking if it's less than that. We're setting it to valid equals false. So if I bump this way up, then you're going to see that the stars aren't generating within the orbit, but really we wanted the exact opposite. So we wanted greater than, and then this would be back to that value. Let's put this here. And then for this, we would say, well, the I has to go back to planet count minus 1. Put that there, and then one of these. And this needs to be divided by 2. And now we've done it. So we've got, hopefully that makes sense. Sun size, we're just calculating the distance of that final orbit divided by 2, and then the stars generate within the outer orbit. And if we bump the number for the stars way up to 10,000, maybe we drop this distance down to 2, and we generate. Now we've got a ton of stars within that star field. They're really closely packed, but they shouldn't be touching. The only reason it looks like they are touching is because I've got the size of the stars bumped up so that you can definitely see them on the video. So you can adjust these parameters to whatever you want. The last thing I want to talk about, now that we've got a fully working system, is just the color. So the color is really simple. We are going to say, after the background, after we set the background, we're going to change the color mode to HSB 360, 100, 100. I do have a video on HSB color mode, but the gist of it is that we're changing to hue, saturation, brightness. This is the range for the hue, this is the range for the saturation, and this is the range for the brightness. That makes it really easy to generate colors that are of the same types of parameters. So we could generate a random hue, but we keep the saturation and the brightness the same, and then the colors will be pretty complementary, even though they have different hues. So we only care about the color really when we're generating the sun and when we're drawing the planet. So we'll start here. We'll say let C equals random 360. So that's going to be our hue. And then where we do all of the strokes and the fills, we're going to use that color. So fill C, and let's do a saturation of 30 and a brightness of 100. Let's just start there. Okay, so the sun, now the sun has a color. When we fill and use the stroke within the orbits, we need to pull this stroke in since we're going to be changing the color. So for the planet, we'll say, so right after we draw the sun, this is our first color, this is our first hue. I guess I could set that, yeah, that could be set to something else, but we'll just call it color for now. Right after we do the sun, we want to increment the color by, we could say, it doesn't really matter, we could say 70, and then we just want to keep that consistent. And then after we draw every planet, we're also going to increment it again. So we say C plus equal to 70. This is a little hacky for now, but it'll look cool in just a second. And then wherever we do stroke and fills, we just want to change it to the same thing we set up for the sun. So stroke C3100. For this fill, well, that's the background, so we definitely want to make sure we're still filling with the background color, so we'll just set that to all zeros. But here we're back to using C3100, and let's just check on that progress. Okay, so we change once, and then we don't change ever again. Oh, I think the issue is that, so we set this range for our color mode at 360 for the hue, so everything above 360 doesn't really have any meaning, right? It's just going to kind of max out at 360. So while we're incrementing the number, we do want to make sure that we're always setting it. So when we go up here, we want to make sure that we set it to a range within 360. So we can just say C equals C mod 360. And then we'll do the same thing at the end of the loop, just to keep it from going above 360. And then we come in here. Now the colors are exactly like we want. And we have a complete system, just like I showed you at the beginning, where we're generating these nice low saturation colors, orbits, stars with circle packing, all within the outside orbit. It just looks really cool. So that's how you do it with p5.js, the JavaScript version. I do want to hop over and show you the Python version very briefly. So here's the Python version within this Python processing module. But there's really not much to show here other than just to show you that the logic is almost exactly the same. I set up a stars array. There is one thing I did differently. I generated the planets, and this was just when I originally wrote the program, and I might would do it differently now. But I generated the planets, and I kind of pushed them onto this list. So I go through the planets here, and I'm just creating this long list of planets where they have their size. There's kind of random sizes. And I don't think I ever even ended up using that, but they have their color as well. And then when I draw the planets, I just step through that list, and I draw the planets in the same way that you saw before. So the rotation is a little bit different maybe. I'm still using the HSB color mode. The stars are using the exact same logic about determining their validity in regards to each other and the center of the solar system. I showed you about the planets. I am drawing the stars separately, and I'm saving the image. But for the most part, I would encourage you to check out this version as well if you're interested in getting started with Python processing. You can kind of compare the differences between the JavaScript version and the Python version, but I mean, really, they are almost identical. And I can run this, and you'll see the image is almost exactly the same. Yeah, the image looks almost exactly the same. I don't know if you'll be able to see. I think I changed the brightness on the sun because that looks a little dull. I don't know if you'll be able to see the stars, but that's just to show you that the Python version and the JavaScript version are almost identical. I hope you enjoyed this video. I feel like I got a little out of whack maybe in the middle of the tutorial and things started getting a little complicated. Overall, it's a really simple concept. I think it's a lot of fun to work on. Hopefully you enjoyed it. If you want to play around with this tool, I'll put a link in the description, and you'll be able to check out the source code for the tool and the Python version and whatever you'd like. So if you're watching this video, I really appreciate it. Thank you very much. And if there's anything you want to see in the future, leave me a comment. Make sure you hit the subscribe button because that would help me a lot. And I look forward to seeing you in the next video.